Alright guys, day 7. Now, you just had homework that dealt with fundamental theorem of, second fundamental theorem of calculus. Okay, and there were these weird graphs that I wanted to show you something real quick. If you go to my home page, and right here on AP Calculus, there's a resource link underneath. Okay. Took me a little bit to build this, but it would have taken me 20 more hours had I done all this work myself, which I was about to do last year around this time, around March last year. I sat down and I built a website. And the website that I built was to help anyone, not just Prosper students, anyone that had access to this, find a plethora of multiple choice questions, as well as free response, as well as even videos to certain questions. So here you have calculator, non-calculator parts, and you have the keys attached, and it's practice. Okay? And I'm sitting there and I'm like, you know what? It'd be cool because I could help infinite number of students if I recorded videos of the last 10 years of actual AP free response questions. And I was sitting at a Starbucks and I started to record it. And after I recorded the first year, all 6 AP free response questions and explained each one so that people could understand them, I was like, man, that's a lot of time. Because each one is about 15 minutes to 30 minutes because I'm explaining, not just doing. You see what I'm saying? So it took me a while, and then I got on YouTube, and I found this guy. And I opened up the video, and sure enough, I'm watching it, and he uses a whiteboard. And I was like, ooh, okay. Kept watching the video, because some of these old videos, like some of these people that record are in their hundreds, and they're using like they're old people, right? And they're using these TI-84s, and I'm like, I don't teach with TI-84s. So I watched this guy, and what caught my attention was his colors. He uses colors everywhere, which I do. Highlighter, he uses blue and red. But what furthermore caught my attention was that he used the TI Inspire. And I was like, are you kidding me? I was in love already. So, looking at free response questions, if you clicked on that tab, and guys, this right now, I usually don't get till March, but the level of questions and frustration people had on this homework packet was actually kind of inspiring and motivating. It's just a completion grade, okay? I'm not looking for accuracy right now. If you felt that frustration, that's good, because it tells me that you are killing it with those second fundamental theorem problems. If you did feel frustrated, 2 things either happened. You didn't do the homework, or you're just like, we'll see what happens. You see what I'm saying? We'll see if it's completion. But on that note, look at right here on 2018. So I have 2018 right here. I'm already using highlights on these things. So it shows you the calculator and the non-calculator questions that are on this thing if I were to click on it. If I were to click on this specific PDF file, it will take me to what those questions are. And this is a blank form, okay? Now, taking that off and going back to the website, I'll just click on it. You can see the scoring guidelines. The scoring guidelines here are basically just the key. So this is the key that tells you what are the answers. And it also tells you, I'll give you 1 point for this work, I'll give you 3 points for this answer and this work. Guys, this right here is what we normally do after we finish learning everything, and we go back and we learn how are they going to grade it and how many points are they going to give us. And you're doing it way early, which is awesome because you're going to already see the level of accountability for said free response questions. Right here on videos, if you clicked on videos, it will take you to the symbol loop. And right here, I've very neatly organized for you at the very bottom left, starting from 2018 all the way to 2010, every single question that I did not have to record after all, that would have taken me 20 hours to do. And if you click on it, it will take you to this playlist on my YouTube channel, and 1 through 6 are already done for you. So this is huge of what resource I'm giving you right now. You have no idea how big this resource actually is. And if you go on the website and you find where it says free response, you click on that, and you go and you find second fundamental theorem problems, you can get practice with these type of level problems that are, I mean, if you could do this, the test is going to be very easy when it comes to these specific problems. But let me highlight for you. Here is the second fundamental theorem. Here is a Riemann's sum. You see what I'm saying? And let's say we want to do the next year. Let's see what we have there. We have another Riemann's sum. We have another second fundamental theorem. So on and so forth. You see what I'm saying? So this should be a really good guideline for you to study. Okay? Any questions? Yeah?
When is the AP exam?
The AP exam is like Cinco de Mayo this year, May 5th. Cool? Alright, so we will cover some of those questions, if not at least one, at the end of class. But now we're going to move on to the new stuff, the good stuff. Okay, and I'm talking about U-Substitution. Okay, second day of U-Substitution. You're going to see today why we need a second day of U-Substitution. Alright, here goes my analogy. This is going to help, I hope, in a lot of ways, what we are doing today. So this, pretend that this is a pen. Right? Now, those of you who have ever been bowling, you know that there's a sweet spot. Depending on if you're left-handed, right-handed, or it doesn't matter, the sweet spot is a different location. But nonetheless, if you aim for the sweet spot, you will get a strike every single time. So what we're doing is we're going to aim for that sweet spot, which is about here. So you are bowling today, and my analogy is basically if you can get the sweet spot, then you've chosen the correct U-substitution, because all the things would be accounted for. But sometimes we may miss. We may miss and not pick up all the pins. Okay? So here we go. Let's go to the problem so you see what I'm talking about. What would U be from what you're looking at right now? X squared plus 1. Okay? du, which is the derivative, and this is my analogy. U is where you chose to throw that ball. Du is the ball in action, and let's see all the pins that you pick up as a result of du. What's the derivative? 2x dx. Now let's come over here and see how many of these did you pick up. So you picked up this and this, and your U-substitution will pick up all of that. Hit a strike. You hit everything down. Okay? So your rewrite is going to be what? 1/2 of the integral u to the third, right? du. Now here we go. It's not 1 to 2. So right now, these bounds of 1 and 2 are in X language. Okay, and the analogy that I used this morning, if you want to use the analogy, that's fine. We're going to go through the nether portal, and we are going to place our 1 where X belongs. And see, I'll do purple, duh. Nether portal is purple. So plug in 1, and what would I get? What would it spit out? 2. It would spit out a 2. And guys, right now we're in the nether world. And 1 is 2. Okay? Now if I plug in this upper bound in the nether portal, what would it spit out? 5. In the nether world, aka U, we never have to go back to X. We can solve it from here. And guys, I want you to take a picture of this because this is the format that I want you to do on the quiz that you have next class. This is the format that I want you to do on the test that's quickly approaching. Wait till I have everything there, and you'll see all the subtle things that I'm going to tell you. If you're missing this, those are points off. You need this or there's points off, okay? Here we go. This is just a rewrite. What's the integral of what you see right now? U to the fourth over 4. Nope.
No, this is
Times 1/2. There's no plus c because this is an indefinite integral. And we have to evaluate this from 2 to 5. Now look. This 1/2 that was constant multiple ruled, you're going to see on a lot of problems today why I only like to work with this one time. Okay? So what I could do is solve, what is this answer going to be as far as 5 to the 4th over 4 minus 2 to the 4th over 4 and then multiply by 1/2. Okay? Because I can do that constant multiple rule at the very end. I can play that 1/2 at the end. I know that this one's an easier one, and it's easy for a couple of reasons. It's only one term. So I could, if I wanted to, put this together as u to the 4th over 8 and evaluate it then. The reason why I like to do constant multiple rule is I like to keep all my numbers small as much as I can throughout the entire problem. Because if you don't, be careful, especially on the quiz tomorrow and the test, some of these can get out of hand. Okay? Yes?
So, if you change the terms, like, or the bounds into, like, the terms of u, does that mean you don't need to replace u with 2x or x squared plus 1?
Correct. You never have to go back and replace it back with x.
But if you were to keep the same bounds, you
Let's
would
get there.
replace
Let's get there, okay? Real quick. Real quick. Let's finish this off. We have u to the 4th over 8, 2 to the 5th. Now, some of you are like thinking to yourself, Mr. Gomez, last time you put these brackets and then you had 2 to the 5th. You could do that. If you want boss status, don't put the brackets. These are kind of like the brackets. This is what you'll do in college. They don't put brackets. It's just the bar with the equal sign. That's your brackets, if you will. And when I plug it in, I will get u to the, or not u, I will get 5 to the 4th over 8. And I will subtract 2 to the 4th over 8. What's 5 to the 4th? 625. And then 2 to the 4th? 16. So from 16, let's go to 25. So I'd add 4 to go to 20, 5 more to get 9. So this is 609 over 8. You don't have to simplify. In calculus, you don't have to simplify. There's sometimes you have to rewrite, but not simplify things like that. Now, let's go back to what Christian said. He said, from here, we don't have to go back to in terms of x. We don't. If you chose to, one, you're going to give yourself a lot more work. And you may not have enough time to finish that problem. But if you did, it would look like this. So, replace u with your original u, and it'll be to the 4th all over 8. But it wouldn't be from 2 to 5. What would it be? From 1 to 2. And if you plug in 2, you get 4 or 5 to the 4th over 8, which is exactly what you already had down here. If you put 1, you would get 1 plus 1 is 2 to the 4th. You already had that. So don't go back. If it's a definite integral with bounds, which you'll have a number answer, don't go all the way back to x. Stay in u, finish it off. But here's where I'll count off points. Ready? If you're not careful. I'm going to be looking for this. When they did the u, did they put dx there? On the rewrite, did they put du there? I'm going to be looking for that. Most important, on the rewrite, did they change those bounds? Because if you left that as 1 to 2 throughout when it wasn't supposed to be, it will be wrong. Okay? Now here's the thing. Some people said, well, could we just keep it in terms of 1 and 2 throughout the whole thing? If we want to go back to this, I'll go, and I said no. everywhere where you would have a u, if you have 1 and 2 there, those pieces will be wrong. Because you have the wrong bounds for the wrong term.
Even if you automatically made that
Yeah.
step 1/2, 1, 2, and then plug in x immediately.
Well, here's the thing. If you plugged in x squared right here immediately, and you wanted to keep this as 1 and 2, this is okay, but this is still wrong. You see what I'm saying? Like, if you kept this as 1 and 2 here, that is wrong because you cannot have 1 and 2 with u terms.
And you have to have a step where you put u.
Yeah. We're going to do a lot of these today, okay? You're not going to be able to get all your answers from one question. Yeah.
Well, you said we're not supposed to use the brackets.
So you don't have to. I want you to just keep watching the notation.
But you said like use a bar only.
Yeah.
But if you're, let's say you have the 1/2 outside.
Well, wait, we have more problems coming. I know exactly what you're saying. If we do, nice question, by the way. If we have the 1/2 constant multiple
So
rule,
it'd be, like, confusing.
use the brackets
Yeah.
so that you don't confuse. Nice. All right. So here we go, guys. We have a lot of questions. This is why I don't want to do this bonus point wise today. I wanted to do as much with you as I could. Okay. Keep the questions coming. Here we go. So here we go. All I see right now are 10 pins. I'm about to knock down. And you'll understand my analogy when we get to the more difficult ones, okay? So, U is where I choose to aim this bowling ball analogy. Okay? What's my U?
1 plus 2x.
1 plus 2x squared. Okay, so now, let's throw that ball. And what would the derivative be?
4x dx.
There you go. So one person would not have forgotten that dx. Please don't forget the dx, okay? I really don't, and it hurts me. Every time I do it on the quiz, I want to take points off on that, but a lot of times it does happen. All right. Let's see how many pins I just knocked down with that analogy of throwing that ball. I just picked up all those pins. Okay, yes, my U assignment will pick up all of these. So the only thing with my rewrite that I have to remember is what? 1/4, because of this 4 that was extra. Okay? And if you don't see it that way, guys, divide both sides by 4, and now you see the 1/4 du is going to be in your rewrite.
And on the rewrite, you want us to have negative powers.
So on the rewrite, from here, I would want you to write it as 1 over the root of u. You with me? Which, yeah.
Couldn't you have du over?
You could have, yeah. So there's a lot of variations here, and you guys are going to see, like whenever you try to help each other out, your work is going to be different, because some of you understand fractions differently than others. Some of you would see this. Some of you would see this. They mean the same thing, because du's denominator is 1. Okay? But the one that I'm hoping that everyone would rewrite it to, so let's come over here, will be 1/4 of u to the negative 1/2. But since this line, I would have taken points off. Can someone tell me why? The bounds. I need my bounds. These are definite integrals. So let's go through that nether portal. What would that be? 1. What will this be? 9. And you immediately on the rewrite change those bounds. Okay? Now this is important what I'm about to say. Notice my work of progression. I want your U-substitution and then the rewrite to be vertical. And right here, when you get to this spot, which guys, I only did this arrow because I ran out of room and I want people in the back to be able to see. I want that work here. Okay? And right next to it, this is the last thing that I'm looking for point-wise, is I want this to be all grouped together. Your rewrite with new bounds, not forgetting du, ready to integrate, and here comes my antiderivative. All right, here we go. What's u to the negative 1/2 going to become?
U to the 1/2 times
Yep, u to the 1/2 times 2 over 1 times 1/4, okay? And it's evaluated from what? From 1 to 9. That's exactly the notation that I'm looking for. If you chose to keep a bracket, you could do this, that would be fine. Yes?
So on the left, did you make it a negative exponent to integrate?
Yeah, I made it a negative exponent so I could just do reverse power rule, be done with it. Cool? Alright, here we go. This 1/4, I'm going to choose to multiply right now, because it's going to reduce this to 1/2. Okay, and you'll see whenever the other examples that are coming of when I use that constant multiple rule. So this is u to the 1/2 over 2 evaluated from 1 to 9. And these colors help so much, I hope they do. Okay.
I'm making that square root of u doesn't get ones off or anything.
Now, if you make that square root of u, it's the same. So look at that. Plug in 9. What's the square root of 9? 3. So 3/2. That's f of b. Just plug in 1. 1/2. So my answer is 1.
It's crazy, bro.
You can use constant multiple rule for all of them.
You can for all of them. Yep. You'll learn that it's not necessarily needed on some of them
Oh, it's the numbers.
because it's one monomial that's multiplied glued together as one term. You'll see what I'm talking about in a bit. Okay.
I really like not having to change bounds back.
Oh yeah, for sure. Just don't forget to change them back for indefinite integrals, right?
Well, why would you get bounds for an indefinite?
No. I meant change your u back to in terms of x.
Oh, yeah.
Yeah, and then don't forget your plus c.
But that one makes sense because you're not gonna have
Because you're gonna
like
have
an
bounds,
x
so why would
plug
you
in.
ever?
Yeah.
So.
Yeah.
Are we good?
You were saying you want that stuff together, do you mean like horizontally?
Yeah, I want horizontally, I want this stuff together. That's what I'm looking for. Remember when we used to do derivatives a long time ago and I said, what you simplify to will tell me if you did all that work correctly? This right here will tell me if you did everything correctly. Okay?
Wait, so you only go back to x
If it's indefinite, there's no bounds. Okay, here we go. Great questions. Keep them coming, guys. Here we go. So let's do some trig. And on this trig, again, my analogy, and you'll see in just a bit when we do them, I just want to condition you to it. I want to aim properly. What do you think u should be? 3x. Okay? What's du? 3dx. Let's see what pins we just picked up. Because I threw that aim, which is right here, and I picked up this dx, which is right here. And if you need to, again, move that 3 over so that you can see where you used to see dx, you're now going to write 1/3 du. Now look, I'm going to put it all the way I want you to see it. Okay, here we go. The way I want you to rewrite it. So this will be 1/3 du. I'm going to put these through the nether portal. What will my lower bound become? Pi over 4. I'm going to put this in my nether portal. What will my u become? Pi over 3. And what is the integral or the integrand that I'm needing to write? Sine of u. What is the coefficient of that u? 1. That's why now it's easy and we can integrate that just like this. Before we couldn't. There were more steps. Okay, so like Jordy said, horizontally from here, we want to find the integral of sine, which is what? Negative cosine. Watch, here we go. Negative cosine of u, watch very carefully please, times 1/3, and it's evaluated from pi over 4, bless you, to pi over 3. Now, if you were listening to what Omar and I were talking about when we were talking about constant multiple rule, I could treat this as one term, which it is because it's multiplied. Or I can constant multiple rule out that negative and just evaluate this and then distribute the negative afterwards, the negative 1/3, which is what I would want you to do. It's equal, but mathematically it's faster, more efficient. You can see pieces clearer. It's organized work. Okay, watch. 1/3 is bracketed out. And you tell me, what would the cosine of pi over 3 be? 3213? Yep, 1/2. Minus, what would the cosine of pi over 4 be? Root 2 over 2. Nice speed. So right now my answer is 1 minus root 2 over 2, all multiplied with a negative 1/3. And the way that I want you to write this is like the following. You could write this as a negative 1 minus root 2 over 6. You could write this as a negative 1 plus root 2 over 6. I hope you see what's happening right now.
So you just wanted a 1.
Or you could do 1 minus root 2 over negative 6.
So you want a common denominator, no matter what.
I want it, yeah, common denominator, but the thing is that I'm trying to see if people saw it, is that there are understood parentheses here, in the numerator and the denominator, to where if I distribute the numerator piece, these appear. If I were to distribute this on the denominator, this would appear, but not both. Good?
Wait, why is it 1 and not 2? Oh, it's multiplying, not subtraction.
No worries.
Why is it negative 1/3?
Because what's the integral of sine?
Oh, it's negative.
It's negative
Oh,
cosine.
so you took it out.
Yep. Good?
But so like the way I'm writing this, it's like going down like that.
That's
but
fine.
You still want those two pieces to
Yeah, so the way you write it, ultimately, going back to what Jordy was saying, I want this piece all on one horizontal line. That's what I'm looking for. Okay? Alright. So let's get more involved. Let's see the ones that. Okay, so this one. Yeah, we could do that. No, that's kind of repeating stuff. Here we go. This is what I'm talking about. This is why my bowling analogy came up today. Alright. Where are you aiming? Where are you aiming? 2x minus 1. Okay, so now let's du is the derivative, the rate of change, the velocity. Let's put that ball in action and let's see what we picked up. What's the derivative? What's the differential between 2x minus 1? 2dx. So this is the same as 1/2 du is going to replace everywhere where I used to see a dx. Look at the pins that we just picked up, guys. We picked this up. This is the ball that we threw, or the aim that we threw. And this is where my analogy comes into play. You missed a pin. So you threw your bowling ball, right? And you had this big old awesome almost strike, but you still have one pin remaining. So if we go back, this is how we pick up the spare. Ready? Using this U-substitution, let's solve for x. Add 1 to both sides. And what? Divide by 2. You see that? So now I'm going to pick up my spare. Let's pick up the spare with blue. This going to go right here. This is new. This is different. So now let's do the rewrite. Don't be afraid to make a mistake. Jump in there. How do I start this rewrite?
U plus 1 over 2.
Before that, 1/2
U plus 1 over 2.
u plus 1 over 2
Times the square root of u.
times the square root of u du. Nicely done. Something's screaming at me right now. What is it? Not bounds, because this one's indefinite.
Got a lot of u's going on.
Have a lot of u's going on, but do y'all see constant multiple rule right now? What could I pull out?
1/2.
1/2. And it will make this so much easier. Now here we go. I'm running out of room. I'm going to put an arrow that says here, and here's my whole horizontal piece. Okay, here we go. I'm going to concentrate on this whole horizontal piece that I keep saying. Help me write it out. 1/4. Now look, u plus 1 is going to be left to multiply with the square root of u. This is why algebra 2 is so important. Distribute that. What would I get? U to the 3/2. That's an easy reverse power rule. Plus u to the 1/2. Easy reverse power rule. So together, let's do this together. U to the 3/2 will become u to the 5/2 times 2/5. U to the 1/2 will become u to the 3/2 times 2/3. We are adding those. Plus c. But this is wrong right now. Because of that. 1/4, and it is still wrong right now. Parentheses.
But, and then technically, wouldn't the parentheses extend around the C?
Technically, it would go all the way to the
But it
c,
doesn't
but
matter.
1/4 c is the same as c.
Yeah.
I'll tell you when that matters. We still have like a month before that matters. Yeah.
Is this when you would put x back in?
So now we got to plug in x back in because it's an indefinite integral. This will become, here we go. Watch very carefully. I'm going to distribute this 1/4 on both of these terms. When I do that, do you see that 2 and 4? They're going to reduce to 1/2. Okay, if not, I'll mark them out. This will reduce to 1/2. This will reduce to 1/2. Okay, so I'm really going to be getting u to the power of 5/2 over 10 plus u to the power of 3/2 over 6. And yes, I'm just going to resubstitute my u so that I get 2x minus 1 to the 5/2 over 10 plus 2x minus 1 to the 3/2 over 6 plus c. That's how methodical, that's how neat, that's how everything I want your work to be. Now, right now it should be easy because the colors are there, right? And I'm going to continue with colors, but as we get to the more practice, I'm going to just do it black and white. I'm going to see if you can follow all the pieces. Yeah.
Could you leave it in parentheses with the 1/4 on the outside?
So what I'll say is most of these are like multiple choice. You know what I mean? Multiple choice to where the algebraic manipulations, that's why I teach you to distribute. It's not necessary for free response questions because you're right, you don't have to distribute for free response questions. But it's to build your algebra skills so that you can identify the ones that they're trying to trick you with on the multiple choice. Alright. Let us go. We still have a lot to do. Okay, so here we go. Let's pick up the pace just a little bit now. Let's see where we're aiming. What's u? 2x minus 1. What's du? 2 dx. So 1/2 of du replaces dx. So this is secretly decoded here. This is secretly here as u. And now I got to pick up the spare. Okay, so I got to throw 2 balls down there. So the second piece is to account for what we missed. And right here in extension, yeah, this one's going to be the same. U plus 1 over 2. That's just coincidental. That won't happen all the time. So the rewrite, I'm going to start with the rewrite over here and then work down. The rewrite will begin with what? 1/2. Okay, here we go. So we'll go 1/2. You with me? Now what?
Would you want to write the balance now?
Yes. Or okay, I thought you were going to do this thing here, constant multiple. This right here would go up in the numerator. Y'all see that? And already it looks like it's going to be ugly. It looks like it's going to be u plus 1, don't write this, over 2 over the square root of u du. But what I want you to see is that you can pull out this understood 1/2 and make this into 1/4. Okay? So let me undo that real quick and then just go straight to the 1/4. Okay, so 1/4, and it's going to be x is u plus 1. Okay, underneath we have square root of u, we have du, and yes, exactly here you're going to change the balance. So let's put this through the nether portal, and tell me what do we get? 1. And this one? 9. It's all about the rewrite. We're going to have to rewrite this integral to where it makes sense a little bit easier. Okay? So what I'm going to choose to do is bring up this square root. So u to the negative 1/2. Do y'all see what I'm doing, guys? I'm going to bring that up and join with the u plus 1. I still have from 1 to 9, and it's still 1/4. Say again? Right now, I'm just showing you the rewrite. Here is where I'm about to do the box. Okay? Ready? I'm going to put this as 1/4 from 1 to 9. Here we go. U to the what? No. Negative 1/2. 1/2.
Wait, why?
Because you are distributing this and this, so you add their powers. And 1 plus a negative 1/2, or 1 plus a negative 1/2 is just 1 minus 1/2. Now it's going to be u to the negative 1/2 du. Okay? Here we go. What does u to the 1/2 become? U to the 3/2 times 2/3. What does the u to the negative 1/2 become? U to the 1/2 times 2, or 2 over 1. There is addition in between. What am I missing? Plus c and 1/4, right? So 1/4. Oh, nice catch. There's no plus c because this is definite. So we need the balance. But look, I'm going to keep this 1/4. And right here is what we were talking about with Omar earlier. I would put this from 1 to 9. And after I got that answer, I would then multiply with 1/4. So let's see what we get. This is going to require a lot of stuff together. Okay, here we go. We're going to plug in 9. Remember, we never have to go back to x. Here we go. The square root of 9. 3. cubed, 27. Divided by 3, 9. Times 2, 18. Okay, watch. That's 18 plus, we have to do it over here as well. This is why I do constant multiple rule. There's way too much to keep track of right now. So put 9 there. The square root is 3 times 2, 6. So that's plus 6. That's f of b. That was plugging in 9. So now in black, let's plug in 1. Okay? What's the first one going to be? 2/3. Plus what? 2 or 6, or what are y'all doing? Oh yeah, 6/3. You're trying to get a common denominator right off the bat. Okay, nice job. Guys, all they did was plus 2. They're just trying to get a common denominator. What goes in between these two parentheses that a lot of people will forget? A minus. Because, did you say that? Okay, because it's f of b minus f of a. Okay, so 18 plus 6, 24, minus, what is that? 8/3. And then, yes, you can change this to 72/3. So just multiply by a form of 1, which is 3/3. Did you write that out, or did you do that in your head? 72/3. Did you write that out, or do that in your head? Nice. So 72 minus 8, 64. 64 times 1/4. 64/12, you could say, right? Or you could see that 64 is countable by 4, right? How many times? 3. Wait, my bad. 16. My bad. So this would reduce. This would reduce to 16 thirds. No, you don't have to reduce, but we did it because it could be a multiple choice question. We have to be good with all that algebra. This right here, guys, is why we did so much algebra at the beginning of the school year. Because of this stuff right here. Because you know how fast you're supposed to be able to do that problem? Less than 2 minutes. By the time we're reviewing for the AP exam, you will do this in 45 seconds.
There's no way.
Yes, everyone says
This
that
whole
every
thing?
year.
Wait.
Yeah.
But that I can't
With,
even
like,
write
with
that.
all the
I don't, we're practicing, we're still learning,
Is there
bro.
a shortcut that you're with
No.
all the work and everything? Like
Yep.
written out all
Yep.
the it's just can't even write that.
I believe in you.
What I'm saying.
I believe in you. Okay?
Copy that.
Just trust me.
Seriously.
Alright, here we go. Now, let's go to ones that are more involved.
That was less involved.
Yeah, those aren't. Okay, so let's put them on 1 to 10. I would say what we did right now. So, Jaden, you can see my hand, right? So, what we just did right now, what level, 1 to 10, Jaden?
He's watching TV.
Dude. So look at my hand, Jaden. Right now, 1 to 10, the problem that we just did, what do y'all think the level of difficulty was? 4. That's pretty close. It's 5.
2.
So we have some 9s, we have some 10s, we'll get there. Just stay with me.